These are the frequently asked questions for Algebra 2 for section 66A1. Start with number 13 here. It says let f of x equal 7x plus 5 and g of x equal x squared. Perform each function operation and then find the domain of the result. Before I even start the problem, I'm thinking about the domain and the fact that both of these that we see up here have domains of all real numbers. There isn't anything that I could possibly think of that I couldn't put in for x into both of these situations. However, I also noticed that 13 is about division, and I know that we can't divide something by 0. So I'm going to go ahead and put f of x on the top of this fraction and g of x on the bottom of this fraction, because that's what I'm supposed to do. And then I'm supposed to try to simplify it. But there isn't anything that I can simplify out of this. Because again, canceling is a form of division, and to do division you have to see pure multiplication, and there's addition taking place up there in that numerator. So the problem's done except for the domain. Now, like I said, you start off thinking, hey, I can use whatever I want, but then the realization is we've now created a situation where there's division, and we can't divide by 0. So x cannot be 0, because 0 squared would put a 0 in our denominator. So always a good idea to talk about and think about domain when you first start a problem, and then when you're done with it. And sometimes as you're going through it, you want to make sure that you haven't introduced anything new. So 15 is f plus g of x, and it says let f of x equal 2 minus x and g of x equal 1 over x. We're performing the operation, finding the domain of the result. And for f of x, no restrictions, all real numbers, but g of x, x cannot equal 0. So no matter what, when we get done, even if it doesn't appear to be a problem, we have to say x cannot equal 0, because in the original problem it could not. All right, so we will have 2 minus x plus 1 over x, and that will be f plus g of x. And I'm looking for something that I could possibly put together, and I can't. And if you're thinking, well, but they're both bases of x, well, right, but it's really 2 minus x plus x to the negative 1. Their powers don't match. There isn't anything that we can do with that, because remember, there's no fruit salad in algebra. Apples go with apples, bananas with bananas, cantaloupe with cantaloupe, but you cannot put them all in a bowl and mix them together. So right here, we're done. Our x's do not share the same power, so we're not able to put those together. And then I know that my domain already was x not equal to 0, but I take a look now and see if there's any other number that would be a problem. There is no new number that is a problem. It's still just that 0, so that one is completed. 17 has g minus f of x. So that would be 1 over x minus 2 minus x. Well, I have to distribute the negative, so 1 over x, and then we'll have minus 2 plus x. Again, there's nothing I can do with that. I do not have any like terms that I can combine, and the domain is still x cannot equal 0, because we cannot divide by 0. All right, then number 19 wants us to take f of x and divide it by g of x. So 2 minus x divided by 1 over x. Well, we are well aware of the fact that we do not divide fractions. We multiply by the reciprocal. So that will be 2 minus x times x over 1, which is just x. So when we distribute that, that will be 2x minus x squared. And now we need to talk domain. Now, if we just looked at our final answer, we would have no idea that we can't use 0. If we gave somebody this formula and said, here, use 2x minus x squared, it always works, we would be lying, because the original functions that we put together worked for everything but 0. So we cannot allow somebody to use 0 in our formula. It will not work. All right, then the next ones I had here involved a little more division. and some subtraction. 23, we want g minus f of x. So we have x minus 1, and we're going to subtract 2x squared plus x minus 3. And that means we have to distribute a negative here. And remember to get that to every term back there. And then we can combine some like terms here. Negative 2x squared and x and negative x, those two are going to drop right out. So we'll have negative 1 plus 3, which is plus 2. And again, when I started the original problem, I was thinking no restrictions here, all real numbers. And then no restrictions here, all real numbers. Nowhere during the process of solving this did I ever have to divide or take a square root. And that means that there shouldn't be any restrictions again at the end. So the domain for this is all real numbers. Then 25, I realize pretty obviously with division, there is going to be a restriction on the domain. So for 25, it says we're going to take f of x, 2x squared plus x minus 3, and we're going to divide that by g of x, which is x minus 1. And already I realize that I'm going to have to restrict this so x does not equal 1, otherwise I'd have a 0 in my denominator. And really the only way to be able to simplify this would be if there is an x minus 1 factor on the bottom. Now I don't know that yet, but I'm going to do an educated cheat here to see whether or not it'll work. So I realized my first term was supposed to be 2x squared. This would have to be a 2x because then first times first would give me 2x squared. And if I need a negative 3 in the back, and this is a negative 1, that would have to be a positive 3. Now remember, I'm doing an educated cheat, so I'm not sure this is going to work yet. I have to check it using FOIL. First times first will give me 2x squared. Outside times outside is minus 2x. Inside times inside is plus 3x. That does give me my x in the middle. And then 3 times negative 1 does give me the negative 3 at the end. So my suspicions were right. The x minus 1s are going to drop out. And the answer is 2x plus 3. But during the process of this problem, we had to divide by x minus 1, which means we cannot use 1 in this formula because the way that it was developed, we had a restriction on the domain. All right, I think that was it for that page. Yes. Next page, number 86, let f of x equal x plus 5 and g of x equals x squared minus 25. What is the domain of f of g of x? So I have an x plus 5 up on the top and an x squared minus 25 on the bottom. And to see the restrictions on the domain, I have to go ahead and factor that difference of 2 squares in my denominator. And then realize that my 2 zeros would be negative 5 and positive 5. So this is going to be answer D. Both of those would give us a 0 in our denominator. 88 is asking us to remember how to solve an absolute value equation, or actually, sorry, absolute value inequality here, and it's less than. So our less than means it was less than 5 units away from it on the number line. So that's where you have to make an and sandwich between a negative 5 and a positive 5. And we'll just solve this. We'll subtract 3 from all of these pieces. And for me, it's easier to solve the inequality than it is to sit there and do trial and error on all of these. I can't stand trial and error. So negative 8 is less than negative 2x, which is less than 2. And then we have to divide everything by negative 2, which means we're going to flip the signs. So my number needs to be between negative 1 and 4. So for 88, I'm looking for numbers up there that are between negative 1 and 4. And it has to be 2 because 4 is not included. We do not have an equal sign on number 88. So we have to leave that piece off. And I believe I had one more that I wanted to look at with you. And it was not one of these because I want you to get a little more practice at these. And these actually worked out very nice. Just remember that you check your solutions because we do get those extraneous solutions when we are raising to an even power to solve. I did want to do 105 though, so let me grab a little piece of graphing paper here. And it looks like it cleared out my content. So I will get some general resources on this. Oh, for goodness sake. So, update took that away from me, too, did it? Oh, there, paperback ones. Let me try that one. There we go. All right. So what we want to do here is graph and solve each system. You could very well just put this into your calculator, too. They're both solved for y equals, but I do want to remind you, we've got the 0.5x, and that's 1/2 x plus 1. Quick and easy graphs for these. This is slope-intercept form. So we start at a +1 for our b value, which is the y-intercept, and I can see my smartboard's orientation is off too. And then I need to go up 1 and to the right 2. And then we would make a line. Because the point line plane postulate says, through any 2 points, there exists one line. Y equals 2x minus 2, that b value is down here at -2. And then we would go up 2 and over 1 because you always think of slope as a fraction. And then we would graph that. And it looks pretty good for 2, 2. Just to be certain, you could grab a calculator and you could check it, or you could go ahead and put 2, 2 back in and make sure it's going to work. And 2, 2 is going to work in the top one and in the bottom one here. So they're both good to go. So this is my solution, the ordered pair 2, 2. And again, you could just grab your calculator and use the intersect feature under second trace for that one as well. That should do it.